Hello, everyone. This is Cameron Wild, and my group consisted of Anna, Kaylee, Calvin, and myself. I hope that everybody's finals week is going well. I know this is a stressful time for everybody, and I hope that it's going as well as it can. Anyways, the title of our slide is Auditory Effects on Heart and Respiration Rate during Continuous Walking. This slideshow is approximately 28 to 29 slides, and the final slide will be for questions. So if you have any, hold it to the last slide and then we'll answer. Moving on. The aim of our study. Now, I want you to envision something with me. Pretend that you have gone to the gym and you're walking on a treadmill. You're listening to your music, you're feeling pumped and ready to go for this workout. Now, this is where our thought process was going when we developed this study. We wanted to figure out if you were actually working out harder because of that music or that auditory stimulus. Therefore, the aim of our study was to determine if heart rate and respiration rate differ when comparing background noise, metronome, and preferred music. The background. During rest, the average person's heart rate is anywhere from 60 to 100 beats per minute, and the average respiration rate is 12 to 16 beats per minute. When someone is walking, it is expected that both of these numbers will increase. During walks, one could expect heart rate to increase to 110 to 120 beats per minute, as well as the respiration rate to increase to from 20 to 30 beats per minute. It is important to note that heart rate and respiration rate do not share a correlation. Just because one's heart rate increases does not mean that their respiration rate will increase, and vice versa. Continuing on with our background. As you can see on the slide, it says, why does sound change heart rate? We found in an article after researching that heart rate increases when noise exposure increases. This snippet was taken from an article, and that article's name was Everyday Noise Levels May Affect the Heart. A quote from that article is that in a study of 110 adults equipped with portable heart rate monitors, researchers found that people's heart rate tended to climb as their noise exposure increased, even when the noise remained below 65 decibels. For example, that's about as loud as a normal conversation or laughter. Moving to the second bullet point, you can see, why does sound change respiration rate? The fast musical tempo causes an increase in blood pressure, heart rate, and respiratory rate, as well as a decrease in baroreflex sensitivity. This was a different study conducted, and they found that fast music tempos cause an increase in blood pressure, heart rate, and respiratory rate, as said. This means that if someone's listening to a sound with a faster beat, they can expect their vital signs to be higher when compared to those sampled vital signs while listening to a sound with a slower beat. Our hypothesis. Our hypothesis going into this was that an individual would have a higher heart rate and respiration rate when performing an exercise while listening to a metronome or music when compared to that of an individual listening to just background noise. This is our method slide. As you can see, it's broken up into 3 sections. I will briefly discuss those 3 sections before moving on, but I want you to focus at first at the top left part where it says N equals 4 participants. This is our amount of participants that we studied, 2 being female and 2 being male. Right below that, you can see it says 3-minute warm-up. Prior to warm-up, though, the participants had to wear a heart rate monitor and respiration belt. This was put on by the other people in the study. Participants did a 3-minute warm-up at a comfortable pace on the treadmill prior to beginning of the actual protocol. When the test began, the participants walked at an incline of 1.5% at 2.5 miles per hour for the duration of 5 minutes. Now, splitting into 3 different categories were the 3 different auditory stimulus that we introduced. 1 being background noise, 2 being preferred music, or 3 being a metronome. The metronome, though, depended on the gender of the participant. Females stepped at 88 beats per minute, while men stepped at 96 beats per minute. Our material slide. The materials in this study were a polar heart rate monitor, which is pictured on the left. It was used to measure the participant's heart rate. The Vernier Go Direct respiration belt, which is pictured on the right, was used to measure the participant's respiration rate. Other materials consisted of headphones, a pre-core treadmill, which was walked on, and the Pro Metronome app, which was used on our phones. Moving on to specifically talking about the polar heart rate monitor. Now I'm going to briefly discuss how to properly use it so you understand how it works and how it functions. First, you have to take off the polar sensor, which is seen in the picture. It's that front piece, it detaches. Then you proceed to wet the inside of the belt. This portion will come in contact with the participant's skin and will help the connection be better. Then you will place the sensor back on the belt once the belt has been connected to the participant, and that belt will be placed below the participant's chest. Then you should make sure that you have a proper connection via Bluetooth to whatever you're using it with. For us, it was our phones. Looking at the other device we used, it is the B.E.A.R Go Direct respiration belt. Now I'm going to briefly go over how to properly use it, just as I did with the polar heart rate monitor. To properly place the respiration belt, make sure that the belt is tightened around the upper part of the participant's chest. The belt should be tight enough that it does not slide around, but not so tight that it is cutting into the participant. This device is a tool that is used to measure human breathing patterns. By using a force sensor and adjustable nylon strap, the device is able to measure respiration effort and rate. Another piece of equipment that we used that was discussed before is the pre-core treadmill. This was obviously used for the participants to walk on during the protocol. The picture on the right is the model of the pre-core treadmill that was used. The speed during testing was set at a constant of 2.5 miles per hour. The incline, which is also kept constant, was set at 1.5%. Now on this slide, the video is playing. This is a sample of what the testing looked like. As you can see, she is walking at a constant pace of 2.5 miles per hour. The incline is set at 1.5%, and this is what it would look like for 5 minutes during the duration of the actual protocol. As you can see on the top right, this is the data that was collected off the Polar Beat app for the heart rate monitor. The bottom right is the data that was collected from the B.E.A.R graphical analysis app. Blue graph is the force of the breath, or how deep of a breath that the participant took. The yellow graph is the respiration rate of the participant during the trial. Statistical analysis. The main statistical analysis test that we used was the ANOVA single factor test. This test was used to determine if there was a difference between auditory conditions for heart rate and respiration rate. This was used on original and simulated data. If the ANOVA test gave a significant p-value, we followed up with a t-test to determine which groups had a significant difference. Moving on to our bias chart. This table is our raw data on how it was collected. There is no need to focus on this data, however. We simply wanted to show how we control for condition bias by having the participants participate in different auditory effects on different days. Now, if you look at the top left underneath day 1, you can see it says music. A participant was forced to listen to music that day of their choice, and the data that came back was heart rate of 148, an average of 122, a respiration rate of 23.53 beats per minute, and a force of 9 newtons. Now, once I said again, this is not important, but we just wanted to simply show that we controlled bias. Moving on to the ANOVA test results. This table shows us the results that were calculated from the ANOVA test, as well as the calculated mean and standard deviation from our data. Based on the results from the ANOVA test, none of the results were considered significant. Results for heart rate without participant 3. We removed participant 3 because compared to other participants, they had an extremely low heart rate. and we believe that this was throwing our data off. The single-factor ANOVA test found that these results had a p-value of 0.945, which is not significant, but was slightly lower than the results with participant 3 being a part of the calculation. With this slight decrease in the p-value, it brought up the question, what would happen if we had more participants? This question will be answered later when we talk about the simulated data. Slide 20. Results for respiration rate without participant 4. Participant 4 was removed because their respiration rate was low compared to the others, as well as way below the normal resting respiration rate, which is between 12 and 16 beats per minute. The single-factor ANOVA test found that these results had a p-value of 0.491, which is not significant but was much lower than the p-value of the results with participant 4 being a part of the calculation. Again, with the decrease in p-value, it brought up the question, what would happen if we had more participants? Once again, this question will be answered soon in the simulation portion. Now for the explanation of the simulation. We noticed that when we remove participant 3 for the average heart rate and participant 4 for the average respiration rate, their p-values decreased. So we wondered what would happen if we simulated having more participants. To simulate having more participants, we took the data for the 3 participants pictured on the top and copy and pasted it 3 more times for a total of 12 participants pictured on the bottom. We then proceeded to run our statistical analysis. We will discuss the results on the following slides. The simulated ANOVA test results. We found that max heart rate, average heart rate, and max respiration rate continued to show no significance with the simulated, but the p-value continued to decrease. On the other hand, though, average respiration rate did show significance at a p-value of 0.02, which can be seen at the bottom right side of the graph, highlighted in red. The simulation average heart rate. The graph on the right shows us that the average heart rate was not significantly influenced by the different auditory effects. Max heart rate and max respiration rate had similar diagrams with their respective data. Since these p-values were not significant, we were unable to run a t-test. On slide 24, we will talk about the simulation respiration rate. The graph on the right shows us average respiration rate and how it was affected by the different auditory conditions. With the ANOVA giving us a significant p-value, we were able to run a t-test. These t-test results had a significant increase from background to metronome, metronome to music, and background to music. Now moving on to our discussion. After completing this experiment, it was determined that heart rate did not respond to auditory stimuli, but respiration rates did. Therefore, respiration rate is connected to an aerobic metabolism, and listening to music can make exercise more effective. In a similar study, it was determined that a tempo of music that participants listened to had a significant effect on exercise intensity. Limitations of our study. There were a few limitations to our experimental design. For instance, our sample size was very small. It only consisted of 4 people. Participants had different daily activities. For instance, one participant was a collegiate athlete. Also, different music genres were listened to during the test. We let the participants pick what they would like to listen to, whether it was country, hip-hop, or rap. Also, while listening to that music, different headphones were worn by the participants. Some chose Beats that covered the full ear, others chose AirPods, which only fit in the actual canal. The argument of track versus treadmill also. We use treadmill, which makes us have to use a set speed instead of letting the participants walk at their preferred pace. And lastly, we found that a clinician should be the one to put the equipment on the participants to make sure that it is used properly. Future directions of this study. If this experiment is to be completed in the future, then we found that a bigger sample size should be used. Also, if possible, the participants should be hooked up to a metabolic cart in order to have more accurate data on respiration, and VO2 max could be measured as well. The treadmill could also be set to a slightly higher speed in order to increase the heart rates of each participant and to determine if the change makes a difference to the overall data. The same type of music or similar pace music should also be used for the participants. This is our reference slide. And finally, are there any questions? Thank you for listening to our slideshow. I hope everybody learned something.